Okay, we're going to factor by grouping, and you do this when you have 4 terms. And you can think of it this way: we're really going to find a GCF for this first part, and then a GCF for the second part. And we're going to use that to create our grouping pattern. Now, the first thing you want to check for is you want to make sure it's in standard form. That means your largest variable with the exponent is first, so x squared is first, and then the exponents get progressively smaller. So then we go to x, and then this one is the constant. It doesn't have a variable at all. Now, what you might be thinking is this: hey, look, these are like terms. I should combine them as 23x. You wouldn't be wrong if you did that, but you would go down a path that kind of leads to nowhere, because we're trying to factor here. So don't try and combine these two middle terms. You'll see why in a few minutes. And then as we get more into this process in coming lessons, you'll see why it's important to just leave these two terms here the same. So don't combine them. Even though that wouldn't be a wrong thing, it just goes down the wrong path. All right, so I'm going to look at these first two terms, and I'm looking for a greatest common factor, a GCF, in those first two terms. And if I look at it, it looks like it is a 4 to me. Don't pick 2. You want the biggest number you can get. So it would be a 4. And then I look for the variables. The first term has x squared, and then the second term has just an x. So the most I can take out is that. So my GCF is controlled by that x. I can't take out x squared because the 24x only has one x. And I'm going to do what we did in a previous video for GCF. I'm just going to do it on these front two. So my GCF comes over here, and then I'm going to divide out my 4x from those two red terms on top to give me a binomial. So if I look at this first one right here, 4x squared divided by 4x, so 4 divided by 4, or 4 over 4, is 1. And then x squared divided by x will just give me x, right? And if you remember this from a while back, right, you subtract the exponents. The exponent right here is really a 1. You just can't see it. So it's 1x to the 1. But I probably won't write it like that. I'll just leave it as x, right? Because 1x to the 1 power is the same as x. And now I'm going to do that same concept for the back term here. So if I look at the back term here, and I do my division for the GCF right there, 24 divided by 4 is 6, and it's a positive 24, so it's a positive 6. And then x over x cancels. And another way to think of that is if you've got x over x, it's 1, so 6 times 1 is still 6. All right, and I know that looks a little messy with those dashes, so maybe I'll try and clean it up for you a little bit. Okay, now I'm going to go to this back term, and I'm going to look for another GCF. It may not be the same GCF. It probably isn't the same GCF. And I note this right here at the beginning. There's a negative in front of these two terms right here. That means my GCF is got to be a negative. If you don't spot that, it won't work right. I didn't have to do that here because my 4 in the front was positive. So my GCF was positive. But here, I got this negative right here, so I need to make sure my GCF is going to be negative. So now I look at what will come out of negative 1x minus 6. Well, the best I can do, I can't pull out a 2 or a 3 or anything like that. The best I can do sometimes is a 1, right? 1 will come out of 1, and 6 can be divided by 1. This right here, the 6 at the end, doesn't have an x, so I'm not going to put an x in my GCF. So this second little GCF that we have is just a negative 1. So I'm going to bring that, put it right here, negative 1. And I'll divide that negative 1 out, and negative 1x divided by negative 1 is just x. And then negative 6 divided by negative 1 is positive 6. So now I've got this term right here, and I'll erase these arrows so it kind of looks a little clearer. Got this term right here, and do you see how these two binomials match up perfectly? if you did grouping correctly, those will be exactly the same. I like to call it the magic. If those two things are exactly the same, the magic happens. I call those the magic. And then these little things up in front right here, these coefficients that are in front of, or these terms that are in front of the binomials, I call those the orphans. So, and can't spell it. And I'll tell you why here in just a minute while I call that. That's an orphan. This is an orphan. And these terms right here are called the magic. This is not in your textbook. This is just something to try and help you remember it, okay? And here's where the grouping part comes together. I'm going to take those two magic terms, and in my final answer, I'm just going to write them once as x plus 6. And then I take my two orphans, and I make a new family out of them. So it's 4x minus 1. Look, let me highlight what I did so you can kind of see. I took the magics that were exactly the same, and I rewrote them right there. And then I took each orphan, and I rewrote it in a new binomial, and I call that the new family. Make sure you get your negatives and positives. So that method is called factoring by grouping, and that's the answer. Now you could check it, because if we multiplied these back together, and you probably learned to do this with FOIL, or maybe something like this with a box. If you multiply those back together, you can check your factoring. It should turn back into what you originally started with. All right?